Oh,
or
we're
at least
live. Oh, well, we're live now. Oh, this is going to be one of those shows already, we can tell. Anyways, welcome to the Carolinas Weather Group. We were experiencing some technical difficulties, and obviously they're fixed because the live button has come up on my screen, so that tells me that hopefully you're watching this right now. So welcome to the Carolinas Weather Group. We are glad to have you tonight as we continue the theme about severe weather and how severe weather affects us here in the southeast. We're going to be talking about the Piedmont Troughing tonight and just how much sea breeze has to do with those summertime thunderstorms that develop over the Piedmont areas of North and South Carolina and parts of Virginia. So we'll talk a little bit about that tonight. We're going to talk I guess that's about it. Yeah, it's severe weather-wise. We're also going to have Peter maybe start off the show. If you've been following along on his Facebook page or even on our Facebook pages, we've been kind of showing you Peter has taken over Philadelphia, so we're going to have him before we start tonight kind of talk to us about what all went down this past week in your life, Peter. I mean, you have instantly got to that superstar status.
well, let's not push it. I mean, but yeah. So last about 2 weeks ago, I got a call from my one of the local meteorologists here on CBS, and she's like, we want to come over your house and do a little like segment on you about all your weather stuff. Whenever I was like, all right. So last Wednesday they came over in the morning, spent about an hour and a half here because they have a new anchor that just came from Oklahoma. So I was showing her a little bit about Philly, I guess, and the weather we get around here. And then Friday, I got invited up to the studio to be there during the morning newscast. Got a couple TV cameos, and then I got my first hate mail later that morning. So, I mean, it just escalated quickly, I guess, last week. But I didn't get any other hate mail any other time this week, so that was good. So I guess everybody enjoyed it, except for that one person on Twitter that said I was too ugly for TV. So thank you, I appreciate the comments. But other than that, it was good. So
There will always be one.
of
Just remember
course,
that. Always will be one.
haters
So.
gonna hate.
Yeah, well, while we have you on the screen right now, how's the weather been up in Philly the past couple of days?
Pretty cool and rainy the whole last week, but this week is supposed to be really good because we have that Omega block that's going to be coming by. So it's going to be sunny in the 60s and 70s all through this week into early next week. So no rain in sight. That's what I like, and I'm ready for some beach weather. I think Scotty can agree with that.
Yes, I am ready for summertime. Bring it on. You guys even got a little snow up there this past weekend,
We
right?
did, yeah. Last weekend I got about a coating over Saturday afternoon, so it's been some crazy weather. And then 2 weeks ago I got a little hailstorm, so it's been up and down roller coaster ride. So what are you gonna do?
I'm done with snow. I'm ready for, like you said, summertime weather.
I hear you.
Let's go down to South Carolina, where it's been a little bit warmer. At least we hope so. Mr. Shea Gibson, who is in Charleston, South Carolina, how are you tonight?
Doing good, Scotty. Doing good. Yeah, we've had kind of a swing of temperatures up and down, some different wind directions. Definitely one of those dynamic months of the year. April is, as we, old man winter wants to try to. He just won't give up, and so we see a swing of patterns here. And so we've had a little bit of everything, north, west. Right now we're seeing a northeast wedge working down the coastline. So we're several days ahead for that. So we got today, tomorrow, all the way through Saturday, maybe even Sunday, and even possibly Monday. So Peter mentioned the Omega block, and it's interesting. We could be seeing Rex block setups on either side, one here in the Atlantic and one in the Pacific. So it might end up looking like one giant hieroglyphic before it's all said and done. But it it may, at this time of the year, it's always a little bit dicey off our coastline with the warm Gulf Stream and strong high pressure to the north, and any short waves or low pressures that develop over the waters off the Carolina coast have to be watched. So not calling anything yet, but GFS is playing around with something off the Carolina coast, and so we'll be watching that for sure. But for right now, we're in several days of moderate to strong northeast winds and gales offshore. So that's what we have right now.
Uh, well, you're a resident El Nino watcher. You sent out a good, interesting tweet earlier this morning, and we've seen some changes in that department as well.
Right, yeah, the Nino 1+2 region took a dive recently all the way down to below 0.5 degrees Celsius, which that would qualify it into the neutral phase. and we're seeing a little bit the Nino regions 3 and 3.4 sort of holding. So there's still a El Nino strength, but we're seeing some less Kelvin waving. We're seeing the thermocline lifting in the Pacific, and that cool water upwelling start to work its way from east to west. Usually you start to see it kind of blotchy halfway through, but yeah, it'd be interesting to see what happens. I think there's going to be not a fast progression, but they're calling late spring into midsummer to neutral phase, and then swinging to La Nina. They're still holding 50 to 60% on that.
Should be an interesting. Well, there, I think I'm muted now. Should be an interesting time, per se, for the next few weeks watching that. I'm going to toss it down to Charlotte, North Carolina, where Mr. Kit's at, feverishly studying away for the last couple of weeks of college there at UNC Charlotte. Kit?
Yeah, forecast has a lot of studying in it for me. But other than that, it's been nice and relatively cool for what's going to be coming for this weekend. I'm really excited for those 80-degree temperatures that are going to be coming in. What about you?
I'm ready for them. I'm ready.
Summer is knocking on the doorway.
And it can't come soon enough. All right, and finally, let's go to Thomasville, North Carolina, where our man, the myth, the legend himself, Joey Mosteller.
Nah, he's just a myth.
Now, Joey's having problems, so it looks like on my screen he's froze. You guys see the same thing?
Totally did.
Oh, well, I heard him. All right, we're going to skip over the legend. Okay, he's back.
Oh, there we are. Okay. But yeah, my computer is not very good. The legend does not have a great computer. I should set up GoFundMe. But
Good.
I should drop in $1 to start really crapping out. Anyway, I was going to take a second because I'm not going to be on because the computer's really bad. It's breaking out off and on. But I thought I would be remiss if I didn't mention one thing that happened in the weather community. Some of the forecasters, some of the guys who watched, some of our guys on TV probably saw guys wearing red this week. It was in honor of another meteorologist in the community, Russell Bird, who passed away due to suicide. I want to get some heavy on the show right away, but that's something that's very close to me. I know these guys here on the group know. If anybody's watching, if you don't know, my father committed suicide 4 years ago. So that's it's kind of an important thing to me when I hear something like that. I don't know the details of what happened with Russell, but I do know that he posted into a group of meteorologists to just communicate, place to go to get advice, things like that from your peers. He posted there a while back saying that he was very, he kind of had a case of blues. He was out of town, away from home. Anybody who's been in the business probably knows a little bit about that. And some guys gave him some advice. Obviously, he didn't take the advice. The advice didn't work. For whatever reason, it led to what happened. Again, like I said, it's very important to me. I just want to make sure anybody ever thinks they're at that point, call somebody. Just get on the phone. Anybody. Call me. I don't care. Facebook, Twitter. Say, hey, I need to talk to somebody. I'll talk. I don't even have to know you. Because I know what it's like to be on the other end of that. I know what it's like when that happens. It's like you committed a murder and you framed all of your family and friends for it. Because they're all sitting there wondering if they did something wrong, if they could have done something different. I mean, it leaves everybody like that. And it's just something, there's no reason to ever go there. So if that ever, I want to make sure I got out of the way and mention him on our show so that we were able to say that. And I know that a lot of people in the community hit them pretty hard because everybody in the weather community at some point in time has had to deal with not being at home, being away and taking that first job in some other city, some other state, the other side of the country, and that struggle that comes along with it. So, again, I just want to say, if anybody ever has those problems, reach out. Reach out to anybody. You can always reach out to me. I don't care if I know you or if I don't know you, but reach out to somebody. So, no great, sunny, happy, Joey forecast from today, but I want to so I think those things.
I'll tell you, and Joey will talk. It doesn't matter about what. He is diverse in every topic, and he will carry on a good conversation with you. So, Joey, we appreciate that, and you're sounding good. So stick around. Maybe everything's worked out on your side of the computer side, at least.
All right, I'll stick around. If it starts to break up, I might cut my camera on and off and just try to.
Sounds good. All right, well, tonight we're going to be talking about the Piedmont Troughing, and I'm going to actually give it over to Shea and let him introduce our guest tonight, who is joining us to kind of help Shea tag team this topic that we're going to be talking about tonight. A very interesting topic, at least if you live in the Piedmont of the Carolinas, Virginia, as we experience those summertime thunderstorms. We're going to actually talk a little bit about how those are developed and some of the big influences over those storms that could possibly go severe. And I would be bad if I didn't mention our thoughts and prayers are with the folks in northern Texas. I'm telling you, they have been hit with hailstorm after hailstorm, and seeing a lot of pictures out of that area of just their houses and cars are just completely destroyed from baseball to softball, grapefruit-sized hail. I know a lot of residents in just north of Dallas area suffered a lot of damage to their homes. So our thoughts are with those guys and hope that they can get everything fixed up before the next series of storms move through. But I would hate to see. I think I seen something earlier today. The same area has been hit within the last 2 or 3 weeks, and they were over 16,000 estimates given out just from the previous storm. That's not counting the storm that just happened a couple of days ago. So we want to give our thoughts out to those guys and hope that they get everything fixed up right quick. And talking about hail, that's one of the producers in the severe thunderstorms that we see here in the Carolinas and Virginia and all parts of the southeast. So Shane, I want to give it over to you so you can introduce us to our guests, and then we'll get started with things.
Thank you, Scotty. Yes, we have Dr. Tom Allen from East Carolina University. He's a geologist with them, and we both forecast with WeatherFlow. We do wind forecasting for the southeast North Carolina zone and the southeast region, which includes South Carolina and Georgia. And one of the things that we look at is what we call the Piedmont Trough. There's different types of troughing that occur along the coastline. We'll see lee side troughing, inland troughing, Piedmont. There's a couple other ones to mention, but we'll stick with this one for now. As far as how these affect sea breezing. So basically, when we talk about troughing, it's low-level circulations that are inland over land. They can be off the coastline, but for intents and purposes of the sea breeze activity, we tend to focus on the inland troughing areas where some of these low pressures spin up thunderstorms and even mesolows at times. So Tom, if you want to introduce yourself from ECU.
Yeah. Hey, thanks, Shay. Nice to meet everyone in the group. Yeah, my background is in geography. Actually, Shay, not geology, but geographers do a little bit of everything. And really, Piedmont Trough, my first encounters with that began as a kid in Virginia, growing up in Richmond. But really, I really recall being struck in grad school at UNC Chapel Hill during the summer months, riding my bike between Carborough and Chapel Hill on a daily basis and watching out for afternoon thunderstorms. And I kind of started keeping track one year, and I counted like 36 consecutive days of thunderstorms. And I thought, what is going on? This is like 4. And years would go by, and I'd come back when I started doing some this part-time wind forecasting with WeatherFlow. That I was beginning to think a bit broadly about interactions with the Piedmont and the coast, and sea breezing in particular. So last year or two, I put together a little presentation. I did some readings. That's what you do with your graduate education, hopefully, and following up on some pretty cool research here in North Carolina. But it also really extends up and down the southeast quite a bit, and I don't know if you want to go into that presentation at all, Shay.
Sure. I was gonna do one thing real quick with the viewers, and I'm gonna share screen and give Okay, let me share screen here and go. Okay, can you see?
Yes.
Everybody see the screen? Okay, good. All right, so just for the viewers out there, when we're talking about the sea breeze, it's a boundary that lines up and down the coastline, and it presses inland as the day goes on. When the sun comes up and the heating process begins, this is a front. It's a cold front, and it actually moves into the coastline versus the other way around. So when we're watching the sea breeze through the daytime in the warmer months propagate inland, we're watching all of this area as well, because these are areas of thunderstorm, and the thunderstorms build. They go very high up in the sky. Of course, you've probably seen the anvils from thunderstorms, and those are very high thunderstorm heads. And when you have winds that travel back out over the ocean and then wrap back into the coastline, that's return flow for sea breezes. And so we're watching these areas as thunderstorming because the winds pick up along the coast from that outflow and then the return flow. And just to give an idea of what we're looking at as far as the sea breeze would look like from the side, here's a side profile, and this is how it works. It's like a giant wind wheel. So you have this cool, moist air coming in off the ocean. It heats over land as thermals, and they rise up, and your clouding starts inland, and then your thunderstorms build. Now, if you have a westerly upper flow or an ocean-bound upper flow that day, then that provides a return flow out over the ocean. So the cooler air sinks, and it goes faster and faster and faster as the day goes on, as those thunderstorms build inland in the convection. This wheel becomes faster and faster, and that's how we get those strong southerly or southwesterly winds along the beach in the summertime. So the sea breeze, it can differ from day to day. It's not always going to be the same, and it may depend on which direction your upper flow is coming from. If it's from the southwest, you'll have a weaker breeze, a westerly or more northwest breeze. From upper levels, you'll end up stronger. So that's kind of the gist of it all. And these thunderstorms can produce a lot of upward flow, and they can. If you notice at the beach sometimes, let me stop sharing here before the screen goes crazy on me. If you've ever been to the beach and you've noticed these thunderstorms inland, you see a whole line of anvil heads, and they're all heading towards the coast, and they never quite make it there. It's because of that drier air at the ocean, that land and sea interface, is keeping that moisture away. The sea breeze front is pushing inland and keeping all that thunderstorming away. Sometimes you get an overrun of those storms. They'll just become so strong, and the push from inland, the Piedmont area downslope towards the coastline, will just overrun the coast, and then you get thunderstorming all the way through to the ocean. But we find in most cases that the beaches stay dry and the thunderstorms fizzle out before they get there. So Tom, with that said, I'll go ahead and we'll take a look at the presentation, and a lot of this has to do where these thunderstorms are coming from. Come from these areas based on soil types and retention of moisture and heat, latent heat that's released as the sun comes up and the land starts to bake. We see vegetative areas and any soil retained from prior thunderstorms the day before, the night before, can spin up low-level circulations. And with that, Tom, go right ahead.
Yeah, so the one of the things, the kind of overall regional structure is that the Piedmont's basically rolling hills, highly weathered mountains, but the soil types in there are generally really weathered. Ultisols are called, kind of clay. You might be known for that. In the southern central part of the Piedmont, you've got the sandhills area. So that's southwest of Fayetteville, down along the North and South Carolina border, and west of there. That's really the center of the Piedmont Troughing. I think has a kind of land cover, land use function or role. Sorry, I don't have the South Carolina map, physiographic map there, but that's an area where the soils really will play probably the largest role in the formation and the convection. So, like the next slide is just kind of reiterating this. You will see the forecasters and the weather forecast offices and weather service frequently referring to Piedmont troughing, and in the middle of summer when heating is really at its most intense, that's when we kind of see this develop. I've noticed it popping up in discussions up and down the southeast coast for several years, but especially North and South Carolina. Next slide is a kind of regional balloon map, I guess, of where that went, but just showing the differential heating. You might know the land cover of the Piedmont also is affected, differentiated. On the coastal plain, we have a little more widespread river floodplains. They're forested. They're really wet, so they're kind of marginal. On the in the sandhills area, you've got thicker sands. Those sands, when it does rain, they dry out quicker. They support a more xeric kind of vegetation, like the pine forest there. And so there's a little bit less evapotranspiration, hence there's more surface heating. And that surface heating provides for a convergence zone relative to the east and west. And it acts a little bit like Central Florida, I think, in terms of convergence, low-level surface convergence, and creating convective type thunderstorms. There's a graphic just showing you kind of typical screenshot photographs of places throughout the Piedmont, in particular focusing on the sandhills. I would always wonder, you look at surface temperature, extreme heat, heat waves in the Carolinas, and this is also the area where you see those highest temperatures typically in the summer. The next slide is a regional map highlighting the location of the sandhills. So it's really a geologic formation that comes through there. It's just in the kind of eastern fringe of the Piedmont, but I don't know too much about the deep geologic history there, but it has something to do with Pleistocene sea level heights and really an area that accumulated sandy weathered soils. The surface rainfall. The next map shows a really swath there also kind of jives with that. So there's I think that was cumulative rainfall compilation from the Southeast Climate Center there at NC State. The next two slides, actually, yeah, the next
Tom,
slide.
I want to make a mention on that. Notice most of that activity is restricted to the midstate and upstate, and the coastline looks a little drier just from the sea breeze holding it back. But I'd love to see one along the sea breeze convergence zones along the coastline, another map there for the 3 states. That would be kind of interesting. I would say,
yeah, because this is annualized, it definitely would mask the, like you're saying, most sea breeze is not penetrating inland very far. You would see a spike there in sea breeze oriented months of rainfall right along just inland from the coast, and that would definitely jibe. Probably is getting masked here because this is a little more annualized.
Right. Okay. All right. Let's go to the next tornadoes.
Yeah. So even though it's there's some effect I think of the Piedmont and showing up in tornadoes. This is a historic map that I found compiled. I think that was from the 80s, but 1990. One way of viewing it. The next map also kind of getting at convection with the lightning and summertime flash densities. This one picks up the Piedmont convection, but especially the sea breeze kind of typical frontal boundaries there in southeast North Carolina. Even there's a nice bubble there, a hot spot around Charlotte, which I think would be jobbing with the urban heat island thunderstorms. The other two maps in succession follow this are from a National Weather Service severe GIS database. So I put together a map of that data set showing all the confirmed tornado tracks, and this is all times of year. And it seemed like there was there's some research going on about whether there's a tornado alley in the Carolinas. The next map is a way of, fortunately, I apologize to South Carolina in this analysis, but this is a tornado track density. So it's actually a measurement in the GIS of the length of tornado tracks per a unit area, and rather strange metric of feet length on the ground per square mile. But you can think of it as a general heat map. So this would include, spring and summertime severe weather, but also if you look at the numerous very small tornadic tracks, and they are also symbolized as the previous map in terms of the EF scale. There's clustering definitely going on that coincides with sea breeze front, with some rarity of tornadic winds there.
And Tom, you could almost correlate that
just
with helicity, added helicity in these areas where the sea breeze is pushing in. It almost looks like it automatically corkscrews from surface up.
Yeah,
And you also
it's pretty amazing.
probably also get some lift right there in the foothills too, which causes that increase.
You see that little cluster, to the west of Charlotte?
Yeah, that's prime time territory for tornado development here in western North Carolina. There's been many times, and just let's see, what was it, kid? Back in February when we had the tornado warning for Lincoln and Catawba, that kind of tracked that same track that it's showing the common occurrence here.
See, it's the one that went through Lincoln Catawba was like in the western portion of it, of Lincoln at least, and like you see that sort of secondary bubble above the large Charlotte, Gastonia, Shelby bubble. It tracked through that one there, the other one around Statesville.
Talking about right? Well, not this one.
I'll see your
Yeah, a couple of years ago we had
this one.
I forget the name of the storm, but a mesoscale complex developed right off of the troughing there in the Piedmont, and it spun up into a tropical storm. I say that because it was literally on top of us here in Greenville, North Carolina. Ran right off the Outer Banks. It's just an amazing thing to watch. So I keep my eyes out on that. It's definitely, even this time of year, I think you're apt to sort of see some of that kind of vorticity basically spinning up.
And I think one thing.
The next map.
Okay, so go ahead, Tom. The location of the troughs.
Yeah, well, this one is an interesting map that some folks at NC State put together. They tried to map convergence boundaries, and so this was announced, I think, from some radar indicated kind of convergences, and then they overlaid them, and so it to me was a neat way of trying to summarize sort of mean location of troughing, and they have both the interaction of downslope kind of breeze, adiabatic, warming coming down from the mountains, but also the sea breeze and convergence coming in from the coast. So you would see a lot of these things happening in that area, and even kind of reflecting convergences showing up in a lot of the Doppler radar nowadays. I know that jives with other folks' observations.
I know that I noticed one thing with the on the tornado map. More in western North Carolina, you get the mountains right there, and just the frictional shear. You can see right around Rutherford County and Cleveland County, at the South Carolina border. There's a higher concentration of tornadoes developing right there because you've got the mountains and the foothills jutting right up as that happens. So you've got the lower convergence zone that you were just showing on that next slide for the eastern half, and then for the western half, you've got again another sudden rise in elevation from the mountains.
Yeah, and to play a little bit off of that, kid, I know that the University of Alabama, Huntsville, their meteorology department is actually doing some research with the foothills of North and South Carolina to doing some studies and stuff about how the elevation, with the cloud level base, the elevation comes up, there's a smaller area or a smaller area for the tornado to touch down as it's rising in elevation. And that's one idea of why we may see more development of tornadoes in the foothills and western Piedmont of North Carolina. So something to watch for the next few years. I know that Brad Panovich has been helping those guys with some information and stuff along with that too. So very interesting stuff here.
Yep. Here's some of that adiabatic warming downslope winds that Tom was getting into.
Yeah, this is just kind of the setup to kind of look for in that. This was a paper by Chris Berman and I think Chip Conrad at UNC Chapel Hill that was probably looking at drought originally. Then we had, I looked for some data on, surface temperatures and satellite data and so forth. I think the next map was put together from another paper. That's actually probably an animation in there or an overlay just to try to look at OBS versus some interpolated or satellite thermal differences there. But you do get this this kind of convergence when you have the downslope and the sea breeze or return flow from Bermuda High at different times of year. Accentuating the convergence. So that coinciding with the thermal differences in the topography, vegetation, I think are kind of multi-scale reinforcement there for the convection we see.
Right.
Next slide. Just that might have been an animation, just kind of the textbook example of some air mass thunderstorms popping up around the convergence there, the Piedmont Trough. Pretty strong ones.
I must have a different version of PowerPoint that won't allow me to do the animation, but I've got some other stuff too. I can also share with some animations. So we'll move on now. You got some really interesting information here about sea breeze circulations and temperatures.
Yeah, so and I'm drawing from some peer-reviewed literature that's a little bit old here, but it was really focused. This is a great paper if you're curious about this, but relating the heat and humidity patterns. And what I was looking for when I was forecasting and Shea came along and it really started thinking a little more about it is how do we think about looking at the intensity of sea breezing. And for me, I like to windsurf. I'd like to shorten my drive to access the water, so I'm oftentimes tempted to drive to a place called Oriental, North Carolina, which is on the Pamlico Sound and the mouth of the Neuse River. So it's a lot closer to home. And so keying in on that is how far will the sea breeze penetrate and at what strength. And that's where the Piedmont Trough is really kind of critical. To that. So looking at interaction, this was some take-home points from another paper. The sea breeze in fronts, will average about 8 knots, and this is, of course, across the entire coastal zone, and there's some studies about the thickness of it. But as Shea mentioned before, that broader reinforcement, that sort of mesoscale reinforcement of the sea breeze, could bring it much further inland, and there's some look at the accentuation of the actual convection that occurs with that. So two kind of rules of thumb that I still am trying to look at. There's in the green and the red when you have a kind of synoptically low-level flow onshore, you typically will not get all of that strong, and this is a biased kind of thumbnail for North Carolina, I guess I would say. But you tend to get a sea breeze that will propagate further inland, but will not be as strong. And in contrast to that, when you have low-level flow offshore, that will force a sea breeze to hug the coast, but allow that convection to be more concentrated and potentially vigorous in terms of sea breeze convection. So oftentimes you'll see a little more intensive thunderstorms hugging the coast of that situation, and the sea breeze won't be penetrating further inland, but it'll be stronger right along the coast. So those are kind of working hypotheses. So what else I've got in here?
Let's see.
Some other analysis of these convergence boundaries and what the controlling features were. Thunderstorm outflow boundaries, sea breezes, Piedmont Trough versus other troughs. So there's been a neat set of studies to kind of deduce what's influencing the overall Piedmont Trough and boundaries there. And I think the next slide, there was a paper in Monthly Weather Review, or Bulletin, I believe it was.
So it shows the temperature.
The next slide shows.
Okay.
That's the temperature, yeah. And the thing we look at a lot, this is up Shea's alley, really right along the coast, forecasting for the sea breeze intensity in the afternoon. And this is just what I think was a textbook situation of a moderate sea breeze right along the coast in the afternoon. You've got various typologies of it, and I don't remember which one this fit, but it was a nice coastal hugging modest sea breeze. The other thing I sometimes have seen, I mentioned the potential generation of sea breeze fronts, and that will show up as well as if you look for those developing.
Cool. So, yeah, I'm gonna stop sharing on that and kind of jump in. Go back. I'm going back to our datascope map, and I wanted to point out how the sea breeze actually is working throughout the daytime as it's increasing its intensity. We're watching our coastal mesonet, and we have an array of coastal stations along along Charleston and up and down the southeast region. So I'm going to show those real quick. And this is how we kind of watch. So early in the morning, right now the winds are from a different angle, but we have 5 stations along the coast, and we have a mesonet saturated sensors all around continental United States, specifically along these coastlines and over the water, so that we can watch this kind of activity occur. As we get in the morning hours, sometimes we see this kind of a setup where these offshore winds, this is from radiational cooling at nighttime, or what we call land breezes, and then we have the sea breeze front penetrating into the coastline, and with our sensors we can actually see the sea breeze working its way in and when it actually arrives to the coast. A lot of times in the morning all of our sensors are offshore, and you have anywhere from a 4 to 8 knot flow, and then you have a little bit of a cumuliform build just off the coastline, and you can actually get water spouts that build from those along the sea breeze before it pushes ashore. So very early in the morning, while the heating process begins, there's a lot of stuff going on out there that we are watching, and like Tom said, with an onshore flow early from low-level pressure gradient force, we have a further penetration, and that all depends on the heating process and what's going on with the storming inland as well. So that's kind of what a lot of times in the morning, this is what we wake up to around 7 or 8 o'clock a.m. or if we're forecasting before that, we'll catch it. This one is actually stamped at 12:25 p.m. So this was a very slow propagating sea breeze front, and it's usually just because there's a very weak pattern in the area where there isn't a lot of like a Bermuda High setup is weak, and let me go out and I'll kind of draw on a map what we look for. As far as weather patterns go, we really look for Bermuda highs to be a driving force behind them. So out here, we have high pressure set up, and that's going to provide a clockwise rotation into the coastline. If we have a northeast Gulf high pressure, this will actually help the sea breeze build because it's giving a clockwise westerly push at the mid-levels or even higher at some points. If we have a jet stream up high that's providing westerly flow plus that northeast Gulf high, that's going to give that return flow. Both of these work in tandem to increase the winds along the coastline. This northeast Gulf high also helps provide that thunderstorm movement from west to east towards the coast. So when it meets the convergence zone, this is what we call the convergence zone, where the sea breeze meets that. This is where all the thunderstorms start popping off inland along that sea breeze front. That's where you see some very, very strong thunderstorm and severe activity going on with hail, possible tornadic activity, and that's sort of the setup that we look for our stronger sea breezes when we get into the season. So let me see here, Tom. I think I've got an actual mesolow, something that you were talking about earlier, and this was caught on May the 19th from the National Weather Service, Columbia. And this was born from Piedmont troughing. All of this was low-level circulation that sort of gathered in one area and just started spinning. And these are the kind of MCVs that you would see produce a homegrown tropical system just off the coastline. And they sometimes will. Most of them fizzle out by the time they get to the coast, and they get torn apart by the sea breeze front. But if we have a weakened pattern without a strong Bermuda high, those will spawn up into they already have the rotation necessary to become tropical. So here's a couple of animations from what you can see is that low-level vorticity from the mesolow that was spun up. It just born out of the daytime, right out of the heat. Here's one of those setups again. This is from, I think, May the 27th of 2014. So I've been watching these setups periodically throughout the years and marking when they're going to actually occur. And here's a map of the Piedmont troughing zone where some of those thunderstorms were coming in. The high pressure ridge axis to the south over northern Georgia, and then above that your southerly to southwesterly flow and your thunderstorming, and the winds came up. If we look at, sorry, bear with me here, I've got a whole bunch of notes I'm trying to get through. Yeah, here we go. This is an example of what happens at the coastline while these storms are marching from west to east. And you can see the sensors here at Folly Beach and Isle of Palms and in Winyah Bay, 60 miles to the north. Here are the thunderstorms coming from west to east, and you can see the winds start out at anywhere from 11 to 15 knots, and then they build as those storms come. So you can tell that the return flow is at work.
It's interesting. Very cool.
Yep.
Now, with that mesolow that was coming in from on the other page that you had up there, with those, like, is it more to do with the high pressure, or is it possibly to do with the fact that as it's coming down from the mountains, it's sort of stretching what little bit of lee side rotation you've got, so it makes it a more tight rotation? Like, which would it be?
I think you have to look at where the heat, you have a lot of different, you have pockets of heat being released quicker, and then you have areas that are retaining the cool moisture air at the surface. And so all of that together, if you have, say, you have 200 square miles of area that got washed over the day before from thunderstorming, and then just to the south, all high and dry. That mix, that thermal imbalance between the two, it depends on how large the area is where you would get that low-level circulation. And if you get enough of that, that's what would cause the mesolow, and also this downsloping feature gathering moisture on its way through from lakes and swamps and any sort of moist areas that also have some of that cool moist air at the surface versus the thermals rising quicker.
Okay, that makes more sense.
And I think there's something going on with the proximity to the east flank of the Appalachians, and you've got a lot of moisture, from thunderstorms there, in the middle of summer too. And the Piedmont area in Sand Hills is really a thermal trough. So then you've got moisture coming down, hitting a really hot pocket, and the amplification of the convergence coming from the offshore high pressure really kicks that bubble up.
Right, and our thermal heat island zones too. So you have any higher populated urban areas that are they're superheating the atmosphere, and so those are especially hot. So then you get even more imbalance, and so more instability means more storming, which means more rotation, and there you go. So that's it's a recipe for it. When we've had a widespread amount of thunderstorms the day before, and the next day we're looking at a Bermuda High setup with hot temperatures, you can bet that you'll see them fire right back off again the next day.
I was wondering if you guys, as you were doing this research, Tom, maybe I seen your slides and stuff. Do you know the ratio, or how many times more if you have a stronger sea breeze that you see severe thunderstorm warnings issued? I mean, did you guys maybe look into any of that? I would imagine, like you said, the stronger the sea breeze, the more severe storms could be. Did you guys take a look at any of that data?
Yeah, I haven't gone back and looked at that. That's a good question. Anecdotally, there should be some data to kind of actually look at that climatologically, like where warnings were issued, and even there is some data on rainfall climatology, and the sea breeze is a really important piece of that in the southeast. But in terms of actual thunderstorms, maybe it would be in some lightning strike data, or just the actual forecast office warnings. I've been wanting to get an archive of that data, the actual warnings and their maps. They've gotten a lot more precise in the Weather Service about drawing those, and then basically kind of build a cumulative map out of those to see how they might compare. It might be a climatological source of information.
And Shea, one thing that you're talking about as we're closing in on the 10 o'clock hour, or 9 o'clock hour, you're talking about when we see these kind of lines die down, we kind of look at those areas where they've died down for the next state for redevelopment. Talk to us a little bit more about how we can see that or spot that in locations that potentially see that more than others, if you can.
Sure. Let me see here. I've got a map here, an actual animation that might give a little bit of insight. It's not the best one that I've caught for storming potential, but it whoops, I got the wrong thing there. Okay. All right, can you see this?
Hold on. Yes.
Okay. All right, so in this animation, you can see that there wasn't a lot of storming activity across South Carolina the day before. There was a undulating front up here above North Carolina into Virginia. But you can see these thunderstorms approaching the coastline, and then the winds come up along southeast North Carolina, but then you see the sea breeze front propagating inland, and that's what Tom was talking about with the 8 kilometers per hour, 8 miles per hour propagation inland. So I don't know if that helps answer your question, but as far as like zones where the thunderstorms might pop, I've seen them a lot of times. They gather a little bit of energy from the upper Savannah River and some of these lakes, like Lake Moultrie, Lake Murray, the larger lakes, Lake Norman up near Charlotte. If you have your westerly upper flow and you have a little bit of a southerly wind coming through there, you can sometimes you can spot those where those origination points are. I've had a little bit more luck finding origination points at nighttime during the nocturnal storming than I have during the daytime. It seems so sporadic, but usually just downwind of urban zones. So those urban heat island effects are the first places I start to look at: Atlanta, Augusta, any of those areas, Columbia, South Carolina, even Greenville, and then we get to Orangeburg is another area, and so you start looking at those little spots. But intensities it really depends on which way the upper winds are going. If you have a southwest flow, generally, they're going to be more widespread along the coastline. You're not going to have as strong as a sea breeze. You're just going to have a southwest general flow coming up from the Gulf, and it's going to be widespread. If you have a westerly flow or even west-northwest upper flow, that's when your intensity becomes stronger in the convergence zones near the coastline. And then if the upper level winds are north, then those usually get, the cloud tops usually get sheared off by a northerly wind. You don't see much activity from that. But you know, your cooler upper flow from the north tends to kind of kill the whole thing. So you can still get a mild sea breeze, maybe even maybe a little bit on the moderate side, but you need something that's going to be coming down from the mountains.
And Tom, one more thing for you. I think I know the question of this being in the weather industry, but throw it out there for those who are watching who are not. Those storms that produce a lot of heavy rain, you're talking about soils and stuff. In the heat of the summer, I would imagine the soils that are a little bit more moist have the potential of condensating and possibly forming thunderstorms over that area. Is that true? The next day?
Yeah, there's some evidence there, you know, but it's I think it kind of random. There's a lot of homogeneity with respect to the soils. You will see the soils kind of drying out quicker in the sandhills, but that's offset from their thermal, you know, specific heating. And so the moisture source from sandhills is coming in. It's from convergence from the wetter soils in the lowlands surrounding them. That makes sense?
Oh yeah.
There's another pocket of this phenomena. It's a really finer scale, I think, around Cape Fear, and you have some sea breezes converging in the I think it's Holly Shelter Gameland, just inland from Cape Fear to the west of Wilmington, and there's a lot more accentuation of the rainfall, you know, kind of from that convergence. I think that's what you're kind of suggesting. We see a little bit of that up north along the coast in the Croatan National Forest as well. But you don't have as sandy as soils there. You have a lot more evapotranspiration going on.
Very good. All right, guys. Well, we're about 5 minutes away. Peter, Kit, Joey, you guys have any questions as we kind of end the show?
No, that was pretty interesting stuff.
Yeah, it's been a fascinating new concept. I mean, I'd heard about it a little bit, but I've never really seen any data or any climatology about it like we saw today.
Cool.
Pretty cool.
Hey guys, I got a little something before we get off the air. I wanted to show some other information. This is kind of neat, and you know, if you want to look at a sea breeze and try to figure out what it looks like from the side, there's experiments that have been done in shadow boxes. I don't know if can you see the screen here?
Oh, all I see is a black screen.
Okay,
Yeah,
hold on now.
here.
Okay,
Still black.
let's see. Let me try again.
Try turning it off and turning it on again.
Hold on.
There it is.
I see something now.
Okay, how about this? We good now?
Yes.
Yes,
Okay.
sir.
Good.
All right. So this is an experiment done in a shadow box. It's done in fluid form, but it does mark what a sea breeze would look like from the side. And you have the sea breeze front, you have the head, you have the Kelvin-Helmholtz billows in the back, and then you have your gravity currents coming in from the back
Hold
side.
on, Shane.
Yep.
We're only seeing the window that has all of the different photos.
Gotcha. Okay,
We're not seeing the individual one.
let me stop sharing on that and try this one more time, guys. My apologies.
It's okay. We know how technology works with our group.
I try to get it to share screen, and then it won't go to where I want it to. And okay, how's this?
There you go.
There you go.
All right, good deal. 'Cause you know how you should share, and then it gives you like 5 choices, and you don't know which one. You just pick one. All right, so Anyways, back to it. So here's the shadow box with the sea breeze front being here, the head rising up, the Kelvin-Helmholtz billows, the gravity currents coming in from behind, your convective internal boundary layer. There's all the structure to the sea breeze done through these experiments. So when we go down and we look a little further at structures, you can see the differences between what type of sea breeze we have. So this would be a weak sea breeze with mainly like a southeast wind. We see this kind of low, flat, very weak, modest sea breeze, and then this is a healthy one in the middle where it's nice and progressive. It's got healthy return flow coming in behind the convective internal boundary layer is nice and smooth, and that's about where the winds would be right along the beach. Those consistent southerly winds would lie right in this area right here. Inland, you'd see all the really gusty and turbulent wind with thermals rising up ahead of it, where that warm air is really trying to climb out ahead of the front. This is kind of like a powerhouse that goes through and it ends fairly quick. Usually the heads might break off, and then those heads propagate inland by themselves as either a gust front or sometimes they just fizzle out. If they do break off and propagate inland as an undulator bore, then it may collide with another gust front coming from inland and create some real fireworks. And we know what that looks like when two outflow boundaries collide. So that's kind of neat. There's some more labeling here, and really one of the things that I've always kind of believed in that sea breeze profiling is that they're very close to sandstorms. They're buoyantly driven gravity waves. This whole structure is very much like a sandstorm. So if we look here, see if this plays. I hope it does. And that is what a sea breeze front might look like if we could see it. It's an invisible force.
How would you like that coming at you?
I think this is
awesome.
really cool, very cool coverage. But that right there is that's what we're looking at. It's not very high, and it sits just low enough where that return flow can come in behind it and feed it, and that's what happens with sandstorms. They get this return flow feeder from behind these gravity currents, and but these are very fast moving. They're a whole different type of gust front, but the same type of properties and nearly some of the same structure. So I just wanted to kind of share that and mention that it's kind of neat to see some correlation there, and if you ever want to see the side profile of one, that's a good one to go to.
Cool.
Well, guys, thank you very much for presenting. Very interesting, and now when we see those summertime thunderstorms, we can kind of know what's behind them. So appreciate all your hard work tonight, gentlemen.
Thanks for having us.
Thank you.
Yeah, no problem. One thing I wanted to cover before we head off is I don't know if you heard today, but the National Weather Service, all of the forecast offices now will be using impact-based warning tags. So I'm going to screenshot that right quick. Some offices, especially out in the Midwest, were already using these, but now these are going to be used throughout the entire United States and all the weather forecast offices. Right now they're just for tornadoes and for severe thunderstorms, but next time that you see a tornado warning or a severe thunderstorm warning, you will see the text. This is, let's look at one that would be possible around here. It's going to be showing you the hazard, where the source of the information is coming from, the impact, and the potential size of hail or even tornado possibilities with wind. So these are going to be rolled out as of today for all of the United States now, not only in the Midwest, but now for everyone. So next time those warnings are issued and you get those and you pop them up on your screen or on your cell phone or something like that, they're going to be read a little bit differently. Not only is the National Weather Service changing that, they are also changing the text format. I hope you guys can still see this. All of this right now is in capital letters, but in the next coming weeks we're going to start to see mixed case letters, no longer all capital, so the National Weather Service is not screaming at you as as per se as they are doing right now with the all capital letters. But some changes coming out of the National Weather Service, so the next time we see some of those products, they may look a little differently. And then next week, I hope you can still see the page, we're going to be talking about corporate America and how they prepare for severe weather with Eric Proas, who is a meteorologist with FedEx. He also does some weather forecasting in the Memphis, Tennessee area, and has also just been recently awarded the National Weather Association Digital Seal. I think he's number 3. So that's next week's show as we talk about severe weather and how corporate America deals with it, and we're also going to be talking about some of his stuff that he does there in Memphis. So again, Tom and Shea, we appreciate you guys coming on and talking to us tonight about Piedmont Troughing. And guys, any closing comments before we head off? Any comments? Any comments on the new National Weather Service stuff? I know it's kind of been a topic of discussion this week with the capital letters going away.
I'm really happy that they're not going to be that they're not going to be yelling at us anymore.
Yeah, definitely going to take some getting used to.
Yeah, it's not going to look as authoritarian. Yeah.
It's not going to be as urgent when they try to tell us that there's going to be high pressure moving into the region and it's going to sit here for the next 5 days. Like, where's the urgency there?
That's it. So interesting changes. I am looking forward to the new warning products. Hopefully, it'll kind of cut down on some of the words and kind of just hit on what's taking place with the storm. So I guess it'll be a trial and error. We'll just have to see how it works out once we get those things issued. So, Peter, any TV appearances for you this week?
No, nothing else happening anytime soon. So I'll just be on here. That's it.
You know, I noticed one thing, Peter, and I'm really disappointed in you about this, but you're not wearing plaid tonight.
I know. I knew somebody was going to bring this up tonight.
Yeah. What did it just you wore it all and haven't got it washed yet, or?
Yeah. I mean, most of them are probably being washed right now, but I only have 2 short sleeve plaid, so I gotta step up my game and get some more.
You say solid colors are best for television.
Yes.
I don't know. He had all the ladies wearing the plaid last week. That was,
I did. I made them wear plaid. I said, "You're not coming in my house unless you're plaid."
Joey was jealous. I'll just tell you that.
I could imagine.
Very, very jealous.
Joey, do you have anything on the new stuff out of the National Weather Service? You are always our controversial one. Do you have anything to add as we before we go off?
I don't have a lot of controversy to say. I mean, Jesus Christ, it's English people. And the rest speak it. I mean, the rest of us type in English. I mean, I'm not sure why there was such a big deal about it. I'm not sure why they kept doing it. I mean, they went to college, and I guarantee they turned in a college paper typed in all caps. They had a failed college, so I don't know. Impact-based warnings, though, we've all agreed on those for years, since they first started talking about them. I mean, it just makes more sense. What's the point of telling people that there's a possibility of 60-mile-per-hour wind without telling them what 60-mile-per-hour winds actually do? So, to me, it's a lot of common sense. Which, the government usually takes a lot longer to come about than anywhere else. So. Yeah.
Now, on the bit with the capital letters, why they had kept that for a while, like it used to be like from, I can't remember what the actual term of it was, but like the old way that they would send messages over the wire, not like through a telegraph, but like the what?
Telegraph. Yep.
Oh yeah, okay, telegraph. It would print out in only one font. They didn't have multi-faced fonts for the text to come out, so they just sort of kept it like that, as that's just how it's always been.
And then think it was all generated from a grid too afterwards.
Speaking of the National Weather Service, Shea has been working hard on one of our shows coming up. He has got an all-star lineup with guests coming on the first week of May, talking about rip currents and tides and stuff like that. So Shea, I want to publicly thank you for the hard work, and you want to kind of tell us a little bit, kind of give us a tease as what to expect there the first week of May before we head off.
Sure. Yeah. Let me try. I'm gonna try to pull the email up and get all the names here. I've got two guys, two Mets from the Miami office. They're actually pretty happy to come on the show. So we got two from the Miami office, one from the Melbourne office, and then I'm working on one from the Charleston office. Ron Morales might join us, but if I can find their names here, it looks like it's going to be a great show, because this is to me and to the National Weather Service a very important thing to talk about is rip currents on the coastline. They've been working very hard. It's been a hot topic for them the last few years, and trying to figure out a good way to convey public information and awareness about rip currents, and when and what days to look for them, and get the word out. You know, we definitely have, especially we've had this whole show on sea breezing, and there you go. So if you have a high tide with strong sea breezes, you have a higher potential for rip currents to start out. So I've been working on getting these guys. I'm working on one more person from the National Weather Service Wilmington office, and then we'll see where we go from there. I think I got Randy Lascady. Let's see. I was talking to Scott Spratt down in Miami. Got Randy Lascady. Robert Mayedo from Miami, and I have to get back to you on the other one. But yeah, it's going to be a great show. We're going to have a lot of really, really good people that have helped put this program together over the last few years.
Very excited. Some information that we all need to know for heading out to the coast, out to the beaches this summer. So we appreciate all the hard work. Tom, again, thank you so much for coming on tonight. We enjoyed it. And everyone, we hope you have a great week. Stay safe out there. Enjoy the warm-up that looks to be coming, maybe, possibly, if that wedge doesn't build in too strong. So everyone have a great week, and we'll see you next week.